This is Math 139, starting Unit 4. The first half of Unit 4 is going to talk about rational functions. Another name for these is algebraic fractions. And you'll see right here in the definition, a rational function is just a fraction that's composed of algebraic polynomials specifically, p of x divided by q of x, p and q both being polynomials. As far as domain with a rational function, the main thing we have to be careful of is not to allow that denominator to be 0. We know we can't divide by 0, so the denominator of a fraction cannot equal 0. If I'm asked then to find the domain, for example, of this rational function, I want to concentrate on that denominator. I know that 3x plus 2 cannot be 0, so 3x is not equal to negative 2, and x is not equal to negative 2/3. Technically speaking, the domain is all real numbers except negative 2/3, although we'll often use this as sort of a shortcut. But I'll write this first one all the way out. With the understanding that when we write this, that's what we really mean. All right, let's look at number 2. Once again, if we want the domain, it's the denominator we need to concentrate on. So x cubed cannot equal 0. If I take the cube root of both sides here, that just says x is not equal to 0. So the domain is all real numbers except for 0. All right, what about 3? A little bit more complex denominator to work with, but the same principle applies. I know that the bottom of the fraction is not allowed to be 0. Now, because this is quadratic, I'm going to have to solve that not equation, I guess you would call it, whatever you want. But I'm going to have to solve that using either a factoring method or possibly a quadratic formula. I think I can do this one by factoring, though. I'm looking for two numbers that have a sum of 8, and the product would have to be 12 times negative 15. I think that's negative 180. And you can play around with that a little bit, but I think 18 and 10 is going to get me where I want to go. Looks like the 18 being positive and the 10 being negative will multiply to negative 180, but add to a positive 8. So let's go ahead and use those two numbers to break apart our middle term. I'll make that plus 18x minus 10x minus 15. And then if we factor this by grouping, factoring out a 6x makes that 2x plus 3. And I'll factor out a negative 5, which also makes this 2x plus 3. 2x plus 3 is my common binomial, and I'll factor that out to leave 6x minus 5. And again, this looks just like what we were doing back in Unit 1 even, I think. The only difference is we've got the not equal to 0 instead of the equal to 0, because we're looking for domain. Here, 2x plus 3 is not 0, so x would not be equal to negative 3/2, and then 6x minus 5 cannot be 0, so x is not equal to 5/6. And so my true domain is all real numbers except for those two values. All right, one more. In number 4, h of x has a denominator of x squared plus 9, and I know I'm not allowed to have that be 0. However, I don't think that ever is equal to 0. This doesn't factor, right? I could subtract the 9 over, and take the square root. So x is not equal to plus or minus, that would be a 3i with the negative under the radical. Because we are only looking at our domains for these functions as part of the real number system, what I'm going to do in a case like this is say the domain is all real numbers. The only problem spots are in the imaginary number system. And for the purposes of this unit, actually, we'll only be working with real numbers. All right, that is the end of part A.